Hello everyone, and welcome back to another R tutorial video. And in this video, we're going to continue our discussion on altering the appearance of layers, specifically talking about how we can derive the color from data. And sort of to sum this up in one word, I would say what we're going for is the idea of a choropleth map. And I want to start with color rather than size or shape, because in tmap especially, color is just a lot easier to deal with. So what I've done here is I've loaded in the New Haven dataset just like we always do, and I've reprojected the two datasets that we're going to be using. So what I want to do first is I want to talk about what happens by default if we attempt to just use a numeric variable to drive color. And so we're going to just quickly throw up a sort of default map. And what I want to do is I want to map the rent variable from the blocks data set. So actually it might be helpful to just do this really quickly just so we're all on the same key in terms of what we're talking about. Blocks, I hope I put the S in there. Blocks data, $sign, and then we're going to do the rent occupied. So this is the percentage of people in the block that are currently renting. And if we run this, you'll see that we have it's a numeric float, which means there's decimals. And you'll see that because it's numeric, that this should be the perfect sort of data set to introduce the concept of a choropleth map. So what we're going to do is we're going to map rent. And as always, you start off with the tm underscore shape, and you tell it what data you want to pull from, and we're going to use blocks again. And in this case, I want to use polygons. Tm underscore polygon, because I want to have those boundaries in addition to the areas being filled by color. So if you see here, when we do this, we have color as a parameter, and we're going to use that to our advantage here. So by default, if all you wanted to do was accept all of the defaults, but have the color be driven by a data set, you would put the name of the variable that you want to use in quotations. So this is a little bit different from ggplot, where you didn't need the quotes. In tmap, you actually need to do quotes. And it is obviously case sensitive, so I have to make sure that I'm careful here. And if I run this, hopefully we don't get any errors, which is exactly what we want. And then map underscore rent. Nope, it'd help if I could spell map. All right. And so what you'll see is what has happened here is by accepting the defaults, right, we've created a 5-class choropleth map of the renter occupation. So I want to talk about what these defaults are and what parameters we can change. And I think sort of there are 3 parameters that you really need to concern yourself with mostly. And those are going to be the palette parameter, the N parameter, and the style parameter. And we're going to talk about each one of those in more detail. So let's start by talking about the color parameter. Or sorry, not color, the palette parameter. I need to make sure I spell this correctly because I always butcher it and then I have errors. So palette. So what palette does is palette actually controls what colors are being used. And this palette draws directly from our color brewer. So you can actually specify in the palette parameter the name of a color palette. And I think rather than going through and sort of naming them all off, I'm just going to quickly show you a list. So these are all of the color palettes that tmap will accept by name. And you'll see that at this website in particular, they're broken up into 3 groups. The first group up here, these are your sequential data sets, which means they start low in one color and they go to darker in that same color. The second set here, these are your qualitative, so you'll see that they have different colors, typically with the same hue, so that you don't have any sort of implication of importance, right? Because the idea with qualitative is that you don't know if one's better than another, so you don't want to imply that. And the third set down here, these are your divergence, where the lightest color is actually in the middle, and then it sort of builds in darkness away from the middle into two different colors. So in this case, it's going through the greens to purples, and in this case, it's going from the yellows to the reds. So we're going to use one of my favorite, which is the blue-green or BUGN color scheme. So what we're going to do is we're going to go back into R, and we're going to copy this, and we are going to change the palette. So we're going to make sure we type it right. And we're going to set this equal to BUGN, typed exactly how it was in our code here, right? BUGN. And if I call this map rent underscore BUGN, and then underscore BUGN, run and run, you'll see that we actually have the percent renter occupied is now a different color. So again, we've now changed the color from the default color palette to this blue-green. And if we wanted to, say, flip it so that the darker colors represented lower values, all we have to do is include a negative sign in those quotation marks. So just to show you what that looks like, simply putting a negative sign inside of the quotes before we describe the palette. I'm getting this flipped and flipped. And if we run that and we run that, you'll see that now the darker colors now represent lower values. So hopefully that makes sense. So that's the sort of quick and easy way that we can use color and change the actual color. The other two parameters that you might need to be aware of are style and the parameter n. Now I want to start with style first because n, the default style that's used actually makes n kind of irrelevant. So changing n without changing style doesn't really show you what n does. So let's talk about style first. So what we're doing sort of under the hood here when we called this by default is we were doing three things. One, we were applying a classification scheme to the data. Then we were using that classification scheme to determine where we should put the breaks. And then we were using the palette to color those breaks. So you can see here that we have these numbers here, 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 and here. But those are all breaks, and those were determined using a classification approach. And that classification approach is controlled with the style parameter. Now, if you were to go through the tmap package and go into the class int package, which is actually controlling this, you will see that there are a whole host of options available for the style parameter. But I would argue that by and large, you really only ever need to be aware of 5 and then the default, which is pretty. And so what I want to do really quickly is I just want to walk through what they are and briefly how they work. So the first one we have is pretty. Now pretty is the default, so let's make sure that we make a note of that. Pretty is the default. And what pretty does is it tries to make the map, and I'm putting quotes here, legible. This is their term. So what this means is that the default value pretty for style is actually going to ignore anything we say about the number of classes, and it's going to do its best to make the map look as good as possible. I personally am not a big fan of pretty, and I wish it wasn't the default because it's a little bit harder to interpret, and in my opinion, it would not be, it's not really the best default, especially if people don't understand what's going on. So for most of the time, we're going to change away from pretty, but just be advised that pretty is the default, and it uses legibility, again in quotes because that's their term, and it ignores the value of n. Okay, that's the first one. The second option is fixed. Fixed allows the user to define the class breaks. So, for example, if we scroll down to our example here, right, we have a class break at 20, class break at 40, class break at 60, and class break at 80. If we were to do fixed, we could put any number in there, and as long as it existed within the possible range of the data set, it would be acceptable, and that would serve as our class break. So fixed allows the user to put specific values in, and this might be useful if you're trying to, say, isolate a specific range, right? You could do 3 classes, one below it, the range you're looking for, and then one above it, for example, right? So fixed definitely has its uses. You just have to be careful because you are defining the class breaks. Next, we have SD, which uses the distribution of the data and standard deviation to pick the class breaks. Oops, breaks. Third, we have equal. So this basically makes it so that each class has an equal range in the data set. And now I'm not going to go through how these are calculated. I'm not really going to necessarily give you my opinion or any sort of facts as to when you should use which one. If you're interested in that, there are plenty of other videos that you can watch that kind of break down the statistics. But just keep in mind that these are different and they will produce a different visual map. So equal, again, makes it so that each class has an equal range. Then there's quantile, which tries to keep each class, make sure that each class has the same number of observations. And I'm going to put in parentheses here mostly. And that's because things like duplicate values can kind of mess with that observation count. But by and large, quantile is going to try very hard to keep each class with the same number of observations. And then finally, we have Jenks. Now, in my opinion, if you're going to do anything that isn't sort of data-based, SD, equal, and quantile are sort of data-based, I would go with Jenks. And this is kind of similar to pretty, but I feel that maybe it's just my background as a cartographer and GIS, geospatial scientist, that Jenks just sort of makes more sense to me. But what Jenks does is it sets the class breaks based on the largest available gaps in the data. And this, again, this may seem kind of magical, kind of like how pretty seems magical, but again, there's numerous algorithms that have been vetted that are able to identify gaps in the data, and the Jenks method will put those class breaks where those gaps are. Hopefully that makes sense. In the next video, we're going to look at actually implementing changing style, and then we're going to look at this n parameter. So if any of this seems confusing, I encourage you to go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.